Alright, in this video we're going to cover the test review for DMA 40. This will probably be split into two parts because it is a lengthy video. We cover every question. Probably what I'm going to do, if you're looking for a particular problem in the video, I'm probably going to cut this one off when we get to the word problems. So we'll cover 1 through 15 in this video, and then we'll pick up with the rest, the word problems and some of the inequalities later on in a second video. But let's go ahead and start with the first problem. We want to evaluate each expression, and we need to show our work. So for question number 1, you have 5x squared plus 7x, and you want to evaluate it for x equal to -2. So therefore this expression, when we plug -2 into x, that's what evaluate means. We have 5 times -2, and we need to square that -2. Notice I'm using parentheses here. I mentioned that in class. When plugging in a number, and if that number is negative, you really want to be careful. Better safe than sorry. Just use a parentheses to plug that number in. And therefore we'll use parentheses here as well. And now to evaluate this, doing order of operations, we don't want to multiply the 5 times -2 first. We actually want to square the -2, so that becomes 4, because -2 squared, -2 times -2 is +4. And this here, 7 times a -2, that gives you -14, so I'm going to go ahead and say subtract 14. 5 times 4 is 20, minus 14, your final answer is going to be 6. And what we're going to do is I'm going to work out all three of these, and then we'll use the calculator to check. But I do want you to show your work. The more work you show, the more partial credit you can get if you get the answer wrong somewhere. I don't want you just plugging it in on the calculator and getting an answer. You can use the calculator to help in certain steps, but get used to showing your work. That's one of the big things about these modules, is showing your work and explaining things. So question number 2. We have -a squared plus 10, and we want to plug -4 into a. So therefore, this negative, we're going to bring it down, and then inside parentheses, we're going to put the -4, and we're going to square it. -a squared. That's exactly what that expression wants us to do. And let's not forget to add 10. Doing your order of operations, this negative comes down. We do not multiply these two together until we deal with the exponent. So therefore, that negative comes here. -4 squared is -4 times -4, therefore we have 16. So this becomes a -16 because we brought that negative down right there. When you square -4, that's a +16, but again, since that negative was brought down, this becomes a -16. And then we add 10, -16 plus 10. Your final answer here is -6. All right, I'm going to box these so we don't get confused. And then question number 3. Let me get some more room here. All right, so the absolute value. Remember, for absolute value, you don't want to take the absolute value until you do everything on the inside. So we have -10x plus y cubed all over -y. And we're taking the absolute value, but we'll do that at the very end of the problem. So plugging in -3 for x and -4 for y, we have the absolute value of -10. Our x value in our problem is -3 plus, and then our y value is -4, and we want to cube that, and this is all over negative. That negative right there is that negative right there. So I'm bringing that down, and then we plug in our y value, which is -4. And we'll take the absolute value of this once we simplify or evaluate this thing all the way down. So still inside the absolute value bars. Working with the top, we can multiply these together and we can deal with this exponent at the same time. Then we'll worry about adding them. So -10 times -3 is a +30. Bring down your plus. And -4 cubed, a -4 times a -4 times a -4 is a -64. and this is all over the opposite of a negative 4. Think of it being read like that. The opposite of a negative 4 is a positive 4. Or you could just remember when you see two negatives beside each other, that does mean it's a positive. Now something else I'm going to do right here in this step before I move on. 30 plus a negative 64. I'm just going to go ahead and say 30 minus 64. And now let's simplify this even further. 30 minus 64, watch your signs right there. That gives you a negative 34 up top, divided by 4 at the bottom. And you can go ahead and simplify this, or you can go ahead and take the absolute value. I'm going to simplify first. We can divide both of these by 2. So we're looking at negative 17 over 2, and we're still taking the absolute value. Now you can make this answer positive. So the absolute value of negative 17 halves is positive 17 halves. Now you can leave it as it's not a nasty decimal. I mean, you could leave it as a fraction, that's totally fine. But 17 divided by 2 is 8.5. So either one of those are acceptable here. Most of the time you've been working through the homework problems, you probably have noticed most of the time you're leaving these answers as fractions, but that's not a nasty decimal, so we can use that as well. Let's check these real fast in the calculator. Checking that first one. See if I can make it fit. There we go. All right, so we're looking at this one right here, 5x squared plus 7x. We should get an answer of 6. And I'm just going to look back here at the problem and make sure I plug the right number in using the original problem. So it looks something like this when you type it into the calculator. 5 times negative 2 squared plus 7 times negative 2. And you do get 6. All right. Now, question number 2, we should get negative 6 for this answer. So we have negative a squared plus 10, and we're going to plug negative 4 into a. So plugging negative 4 into a, it looks something like this on the calculator. And again, you can just follow along right here too. I'm going to pretty much type it in the same way I wrote it down right here. And that's what I did for that example up here as well. I just typed it in pretty much just like that in the previous example. If you recall right there on here in the calculator screen, that's exactly the same way I wrote it down in that first step. So again, going to question 2, we got negative, and then we plug in the negative 4 for a. We square it, and then we add 10, and the final answer is negative 6, which matches that right there. And then this last example, on the TI-30X, I don't think there's an absolute value anywhere. I've never used it on the calculator if it is. So what we'll do is we'll just evaluate the inside, and then we'll come back and just remind ourselves to take the absolute value at the end. Now, if you want to type all this in at one time on this particular calculator, you have to be careful how you type it in. We need to use parentheses, even though you don't see them. We need to be using parentheses here and here to close in the entire numerator and the entire denominator, and then we'll divide between those two. And that may be a little confusing. Maybe some of you would prefer to just type in the top stuff and then type in the bottom stuff, which is just fine. But I'll do it all in one stroke, just everything at one time. So we got parentheses, negative 10, then we have another set of parentheses with a negative 3. I'm typing this in right here with those little dotted parentheses. So plus, and then a negative 4, raise it to the third power. That parentheses closes up that entire numerator right there. Now we can divide, and then our denominator, that parentheses there is this one. And then we have negative, negative 4, and then close it one more time to close in the entire denominator. So what you get is negative 8.5. And if you recall, we said our final answer was a positive 8.5 because we actually take the absolute value of that number. And the absolute value automatically makes it positive. So we got that one right. But now let me go back to here. Suppose you did not want to use those parentheses. So I'm taking them away right now. What you could have done to check, you could type in just the top stuff. Just the top stuff, you wouldn't need those parentheses that I just deleted. So it looks something like this. That matches exactly what the top stuff says. That's going to spit out that negative 34. So there's your negative 34, as you can see right there. And then the bottom piece, I mean, negative 4 is a positive 4. Negative 4 is just going to spit out a positive 4. So that's what you end up getting right there. And then you just want to make sure you continue to simplify the fraction and take the absolute value. All right. Now, question number 2. We want to simplify some expressions, and let's make sure we show our work here. So for this example, we have to distribute the 2/3 to both of these terms inside of the parentheses, and then we'll worry about coming back and combining like terms with the negative 18a. So 2/3 times 15a. 2/3 of 15 is 10. If you take 2/3 times 15, that's going to be 10, so don't forget your a. And now distribute the 2/3 to the 6. 2/3 of 6 is going to be 4. But watch your signs, that's a positive and that's a positive, so we have a positive here. And then we bring down our minus 18a. When we combine like terms, the only thing you can combine are the 10a and the negative 18a. 10a minus 18a is a negative 8a. Just remember to add or subtract the coefficients. And then we have our plus 4. And that's all we can do with that problem. And by showing your work, just that little bit of work there is what I will be looking for. Forgot my equals right there though. All right, and on to number 5. That 8x squared, nothing you can do with it yet. Just bring it on down. Distribute the positive 3, kind of like what we did back here in this last example. But in my honest opinion, this one's a little bit easier because we're not dealing with a fraction. So positive 3 times positive 2x, that's positive 6x. Positive 3 times negative 7, that's minus 21. So I'm just going to say subtract 21. And then be careful here. This is an understood negative 1 that you need to distribute to these two terms. Negative 1 times x squared is negative 1x squared. I'm okay if you write just negative x squared. That'll be fine without the 1. And then a negative 1 times a negative 4. Make sure you watch your signs there. That becomes a positive 4. Negative 1 times negative 4 is positive 4. Let's go one step further and combine like terms. 8x squared minus 1x squared is 7x squared. And what I'll do is I'll just kind of cross those out because it's easy to get your terms mixed up of what you've done and what you haven't done. But again, what I did there is I combined the 8x squared minus 1x squared. I just subtracted the coefficients. 8 minus 1 is 7. You don't change the x squared. Alright, so moving on to the x's. Let's see, all we have is a positive 6x, so that's the only thing we have for the x terms. And then the minus 21 plus 4. Remember your rules for addition. When your signs are different, we subtract the two numbers and keep the sign of the quote-unquote bigger number. So that becomes minus 17. And there is nothing else we can do here. No more like terms. That expression is simplified. On to number 6. Distributing again. 3 times 2y, that is 6y. 3 times a negative 1, that's a negative 3. So I'll write subtract 3. Be careful with your signs here. This is a negative 5 times 4y, so that becomes minus 20y. And then a negative 5 times a positive 3, that's a minus 15, because that's a negative 15. Combining like terms, 6y and the negative 20y, so we think of this as 6y minus 20y, that's a negative 14y, because 6 minus 20 is a negative 14. Watch your signs here as well. Minus 3 and minus 15, those two signs are alike, so you can add them and keep the sign. Therefore, minus 3 minus 15 is minus 18. There's nothing else you can do with that expression. It's totally simplified. And then the last one here, no parentheses, so we don't have to distribute anything. However, we have several like terms to combine. 7a cubed plus 5a cubed, those are like terms. So 7a cubed plus 5a cubed is 12a cubed. But then we come back and subtract 5a cubed there. So you might have recognized, though, that these two terms here, they cancel out. If you didn't recognize that, you could say 7 plus 5 is 12, minus 5 takes you right back to 7. So that positive 5a cubed and that negative 5a cubed, they cancel out. So therefore you will have a 7a cubed in your answer because there are no more a cubes up here. The minus 4a and minus 8a, those signs are alike, so I'm going to add 8 plus 4 and I'm going to keep the negative sign. So you have negative 12a, that's what minus 4a minus 8a is. And then we don't have any more constant terms except for that negative 1 right there. And that's your final answer for that problem. So there's some simplifying. On to the next piece. Time to solve some equations. Show your work here. So this first example, 2x plus 1 equals 7. Showing our work, I'm going to subtract 1 from both sides. Those 1's cancel out because 1 minus 1 is 0. Bring down what we have left over here. Therefore, we have 2x is equal to 7 minus 1 is 6. Now to get rid of the 2, to get x by itself, we divide by 2 on both sides. Therefore, we get x is equal to 3. And that's your final answer there. And again here, just to remind you, those 2's do cancel out because 2 divided by 2 is an understood 1 with the x, and then 6 divided by 2 is 3. So just reviewing some basic equation skills right there, a two-step equation. For the next example, bring down the 5 because you do not want to take 5 minus 2 and say 3. You do not want to do that because you would be disobeying order of operations. We need to multiply this negative 2 times these terms before we talk about subtracting or anything like that. Let me put a dotted line around that. That way we don't get too messy. So I'm going to distribute the negative 2 before I start taking 5 minus 2. Negative 2 times 3x is negative 6x. Negative 2 times a negative 4 is a positive 8. And this is equal to 3 minus x. I prefer to simplify each side of the equation. So we need to simplify this side. 5 plus 8 is going to be 13. And it don't matter how you write this if you think about the commutative property. I'll write the 13 first. It's positive. And then don't forget to bring down your negative 6x. So we have 13 minus 6x on the left-hand side. On this side here, you got 3 minus x. So we've simplified both sides. Now you need to get the x on one side of the equation. I prefer to move the smaller one to the bigger one. Negative 6x is smaller than an understood negative 1x. So we can move the negative 6x over here to this side by doing the inverse operation. Add that whole piece. And the reason why you can do that is because negative 6x plus 6x, they cancel out. Bring down what we have left. We have 13 is equal to 3, and then negative 1x plus 6x, that gives you positive 5x. It's okay if your x is on the right-hand side of the equation. That's something I told you to get used to. You don't always need to have that variable on the left side of the equation. So to get x by itself here, since that 3 is positive, you need to move it. So let's subtract it. 13 minus 3 is 10. Bring down your equals. Those 3's cancel out because 3 minus 3 is 0. All you have left over here is the 5x. And then your last step is to divide by 5 to get the x by itself. 10 divided by 5 is 2. 2 is equal to, well, the 5's cancel out. All you have left is the x. Now, something I have failed to do, but you need to be doing it, is checking your work. And what we'll do is we'll come back and we'll check all of these at one time because I'm already on a roll, I guess you can say. All right, number 10, distributive property, some more. So 2 times x, that's 2x. 2 times 1, that's plus 2 because that's a positive 2. Distribute this understood negative 1 to these terms. Negative 1 times x is negative 1x. Negative 1 times negative 8 is positive 8. And this is equal to x. All right, from here, let's combine like terms on the left-hand side. We got some simplifying to do. 2x minus x, that's equal to, or 2x minus 1x is equal to 1x, or you could say just plain old x. And then 2 plus 8, that's going to be a positive 10 because 2 plus 8 is 10. And this is equal to, over here, we still have x. Alright, from right here, maybe some of you notice it, maybe some of you don't. But it is impossible to take some number and add 10 to it and get that same number back. Impossible. Some of you, I mentioned this in class, you might just go through the motion of solving equations, and if you try to get the x's on the same side, you'll notice that the x's actually end up canceling out, and look at what you have left. Over here, the x is canceled out, all you have left is 10. Over here on this side, x minus x, there's nothing else to show, so we need to put a 0 there. And look at that, that don't make sense. 10 equals 0? No, it doesn't. This is an example of when you have no solution. And the time when you could have really identified it being no solution was right here when we had x plus 10 equal to x. And what I said again was it's impossible to take some number and add 10 to it and get that same number back. Impossible. Because when you take a number and add 10 to it, you're going to get something 10 bigger than the number. You can't get that same number back. So again, you might have recognized it right there. That's a no solution. Let's see what we get for this problem right here, number 11. Bring the 3a down. We can't do anything with that yet. You need to distribute the negative 2. Watch your signs. So negative 2 times a is negative 2a. Negative 2 times negative 9 is a positive 18. And over here on this side, we'll just bring down the 4 plus 2a. All right, 3a minus 2a, combining like terms. 3 minus 2 is 1, so we have 1a, or you could say just plain old a. Bring down your plus 18 from here. Bring down your equals. You cannot combine these, so we'll bring those down as well. 4 plus 2a. Again, what I like to do is I like to move the smaller one to the bigger one, and we did say this was 1a. I like to move the smaller one to the bigger one. To move that 1a over, we can subtract it from both sides of the equation. The 1a's cancel because 1a minus 1a is 0. Bring down what you have left. 18 is equal to, bring down the 4, and then 2a minus 1a is a positive 1a, or just plain old a. 2 minus 1 is 1, so we have an understood 1a right there. And then your last step to this equation is to subtract the 4 from both sides. Therefore, you have 14 is equal to a. All right, now let's check our work for these problems. It's kind of small, but if you're watching this on full screen, it shouldn't be too bad to see. Make sure you're watching it in HD, by the way. It comes in just fine then. So plugging in 3 up here, 2 times 3, plugging 3 into x, 2 times 3 is 6, plus 1 is 7. Yes, it definitely works when we check our work. Plugging in 2 into this equation, that gets kind of crazy, I guess. But let's see, we'll do a little bit of scratch work. 3 times 2, plugging the x in, plugging 2 right there. 3 times 2 is 6. 6 minus 4 is 2. Let's see. I guess I'll come down here and work it out. Let's plug the 2 in here and here. We're going to plug the 2 in. Make sure this works. So we got 5 minus 2. I'm going to work inside of here. 3 times 2 is 6. 6 minus 4 is 2. Hopefully this is going to be equal to 3 minus 2. That gives us 1 on that side. Well, this becomes 5 minus 4. Remember to multiply before you subtract here. 5 minus 4 is equal to 1, so therefore our equation does work when we plug in 2. You can use a calculator here to speed up this process when you're checking your work. We did say here this was no solution, so there's no way to check that. You just got to trust your work. And then this one right here, number 11. We'll kind of do a little bit of scratch work for this problem as well. So taking our equation, plugging 14 into this spot right here. Plugging 14 in, and we're going to plug 14 in right there. So that becomes 2 times 14. And we got to plug in 14 right here. So this becomes 3 times 14. 3 times 14, that becomes 42. Bring down the minus 2. Inside of the parentheses, 14 minus 9 is 5. Hopefully this will be equal to 4 plus 28. 2 times 14 is 28. This right here becomes 42 minus 10. Don't take 42 minus 2 first. Make sure you multiply before you subtract. Over here on this side, we get 4 plus 28, and that is actually going to be 32. And again, I'm just doing scratch work to quickly check my work. 42 minus 10, that is equal to 32. So therefore, that equation does work as well. All right. And the last 4 problems for this part of the video. Solving this equation, no distributive property, we just need to combine like terms. 2x minus x, that is equal to x. You can think of that as being 2 minus 1. 2 minus 1 is an understood 1x. And then over here, 10 plus 2, that gives us 12. Combining like terms. 2x minus 1x is x. 10 plus 2 is 12. Over here on this side, you get 4x plus 6. I like to move the smaller to the bigger, so let's subtract that understood 1x from both sides. The 1x is canceled over here, so we're left with 12 is equal to 4x minus 1x is 3x plus 6. Now let's work on getting x by itself. So we subtract that 6 from both sides. The 6 is canceled right here. Bring down what you have left. 12 minus 6 is 6. Bring down your equals, and we have a 3x. To get x by itself, divide both sides by 3. Therefore, we get 2. 6 divided by 3 is 2. 2 is equal to x. Let's go ahead and check our work real quick. Because these next 3, we can't really check our work too much unless we plugged in random numbers, but I don't want to get into that for the review purposes. So plugging in 2. 2 times 2 is 4. 4 plus 10 is 14. 14 minus 2 is 12. 12 plus 2 is 14. So we get 14 over here on this side. Let's see if we get 14 on this side. 4 times 2 is 8. 8 plus 6 is 14. Now I did all that without writing anything down, but that's just checking your work, doing a little bit of mental math to make sure both sides are equal to each other. And again, all I did there was take that 2, plug it into each spot for x, and made sure that this side right here, is equal to this side right here. Now, question number 13. I equals PRT, and it says solve the equation for t. Since the goal is to get this t by itself. Now, everything else needs to be moved. The p needs to be moved, and the r needs to be moved. You want to ask yourself, well, what are you doing with the p, the r, and the t? You're multiplying all these things, so to move them, you do the inverse operation, which is division, and you can divide by both of them at one time. The p will cancel out over here, and the r will cancel out. Therefore, your final answer is going to be I over PR is equal to t. And you have solved that equation because you solved it for t. You got t by itself. All right, this next one, solving for h. You're trying to get that by itself. So we need to move this 2 pi r, but we got to wait on that. Think of that as just being some number, big number. 2 pi r is some number getting multiplied by h. We don't want to move that yet. We want to move this 2 pi r. The way we can move that is to subtract the whole term. So we're going to do that from both sides. The reason why we can do that, because 2 pi r minus 2 pi r, it cancels out. That's just like what happens up here when you take 6 minus 6. It cancels out. Because up here we were trying to get x by itself, so we had to move the 6 over first, just like I'm moving this 2 pi r over first, because it does not have an h in it. The 6's that we subtracted did not have an x in it. It kind of has that similar flavor. For more help on these particular problems with variables all over the place, check out my video from the module talking about formulas because you have variables everywhere. But anyway, back to this problem. The 2 pi r's cancel out. S minus 2 pi r, there's nothing you can combine there, so the only way you can write this is S minus 2 pi r is equal to, bring down what you haven't used yet, which is 2 pi RH. I just brought all that down. And now, to get h by itself, you want to move the 2, the pi, and the r. Well, since all these things are getting multiplied, we can do the inverse operation of division, and we can divide by everything at one time. Just do it on both sides. The 2 cancels out, the pi cancels out, and the r cancels out. That leaves you with h all by itself. And there's nothing we can simplify over here, so our final answer is s minus 2 pi r. All of it divided by 2 pi r is equal to h. That's our solution for that one. And this last problem for part 1 of the video, 4y plus 3x is equal to 16. We want to get y by itself. Again, if you're having trouble with these, this is a review video, so I am kind of going quickly through these. Check out the video on formulas. If you go back to the wiki, or if you look through my channel, type in formulas and it will pop up there. I have about 8 examples that cover problems very similar to what we're doing here. But since we're trying to solve for y, this 3x term does not have a y in it, so you can move that entire term over. So if we want to move this positive 3x, we subtract the whole thing from both sides. 3x minus 3x, they cancel out. Bring down what you have left. All you have left on the left-hand side is 4y equals 16 minus 3x. Do not combine that and say 13. They're not like terms. The only thing you can say here is 16 minus 3x. And now the last step here to get y by itself. The y is getting multiplied by 4, so the inverse operation is to divide both sides by 4. And just notice I'm doing a long division bar. Those 4's cancel out. That leaves you with y is equal to 16 minus 3x over 4. And you can leave it just like that. So, problems 1 through 15, part 1 of the DMA review. Now, this may have seemed to go quick. It's a quick instruction, but at least you have all the answers here. I highly recommend looking at all the other videos that I have posted where maybe I take it a little bit slower for some examples, especially these equations. I have several videos on solving equations. Make sure you have a peep at those. And also back when we were evaluating some things. We're just plugging numbers in. But that's part 1 of the test review. Part 2 is coming soon. That's it for this video. Hope it helped.